bracket M go to G. Or B go to A bracket M.
We update B to become M plus 1. Right? We update B to become M plus 1 because we know not only A bracket M does not equal to K, but anything that is before A bracket M also cannot be equal to K because they will be less than A bracket M to begin with. And anything that's less than A bracket M is automatically less than K. Okay? So this time, we are not changing the parameter B. We are going to specify the new parameter B to be based on M plus 1. Are we doing okay so far? How we change the iterative version of binary search into a recursive version? Which means the other one is going to be almost exactly the same. A goes to A, fine. In this case, B goes to B. We have to adjust E. Now, this is just saying else, but what is it actually saying? Which case am I catching by just saying else here?
If everything else is false, then do this.
Exactly. But what does it mean when everything else is false? In other words, if B is greater than E is false, that means I still have some elements that have not compared yet that can still have the value K. Exactly. Okay? Because A bracket M is a value, K is a value. They can be equal to each other. One can be greater than the other one can be less than the other one. But those are the three choices. I have checked 2 of the 3 choices already. It is not equal to, it is not less than, so the result is it has to be greater than. Exactly. So that's why I don't have to spell it out. Now, if I spell it out, there's nothing wrong with it. Okay? I can, if I want to, say, else if A bracket M is greater than K, then. It's just that it is not necessary. Okay? For clarity, let's say that we put it back in here. Okay? Just for clarity reasons, it is not necessary. So in that case, we have to update E because anything that is after M cannot possibly have the K. After A bracket M cannot have the value of K. So that means we have to pass M minus 1 to E, and then once again K goes to K. Missing anything? It's not matching up. Oh, I think that has to do with the plus taking up a little bit more space. And that's it. That's the recursive version of binary search. Okay. Is that easier to read or harder to read?
Depends on your point of view.
Exactly. Okay, exactly right. In other words, sometimes recursion is better, sometimes recursion is not better. Okay? What you have to remember, I don't have enough time to trace it today, so we'll have to trace it next Monday. What you have to remember is any algorithm that uses a loop, I can turn that algorithm into a recursive algorithm, not using any loops at all. Any algorithm that is recursive, I can turn it into an iterative algorithm without recursion. In other words, recursion and loops are equivalent in terms of what kind of logic they can express. Okay? It's just a matter of some problems or the solution of some problems. If you express it recursively, it looks a whole lot better. In some other cases, if you use loops, it looks a whole lot better. If you think about the Fibonacci numbers, that can be defined, or the subroutine to do it can be recursive, can be recursionless. It does not have to involve a recursion. But that algorithm by itself will look really ugly. And that's why in this case, we would much rather to do it in a recursive way. So it all has to do with whether the solution or the algorithm or the method of doing things, whether it fits the recursive description or whether it fits the iterative or repetitive description better. In this case, it's kind of a toss. Some people look at this and go, oh, this makes more sense. We just have to look at the other part of the array. And some people look at this and go, well, it doesn't make any sense. I would much rather be moving the bookmark instead. So, it's basically a toss in this case. I will save this file, and that's basically the end of this class. And because of my new flash drive, the recording is working. So some of you may want to watch it again. If you have any questions about the return value, what we talked about today is really, really a good demonstration of how to use a return value. Okay, and also the beginning has to do with the homework assignment, so that's also useful. Okay, I'll see you guys.